how can some stressors on the pre-harvest side impact spoilage and shelf life on the post-harvest level. So trying to look at how heat stress will impact the longevity of that product and that microbial ecology of the final product. And then is there a way that we can maybe use a inorganic or organic acid, something that is either currently on the market or a novel product to try and counteract that?
Hello, everyone. My name is Doug Korver, and I'm one of the hosts of the Poultry Podcast Show. Welcome to our latest installment. If you find this interview interesting, please let us know by visiting our website at wisenetics.com. You can also learn more about all of our podcast segments, which covers poultry, swine, dairy, beef, feed milling, and even pet food. So feel free to suggest a new guest if you'd like to as well. Our guest today is Dr. Dana Dittoe, and she is an assistant professor of meat microbiology in the animal science department at the University of Wyoming. Dr. Dittoe has over 50 publications investigating ways to shift the microbiome at the pre-harvest and post-harvest levels in order to mitigate foodborne pathogens. As well, she's interested in how the use of acidifiers such as organic and inorganic acids have the ability to improve performance, reduce foodborne pathogens, and extend shelf life of poultry and meat products. Welcome back to the program, Dana.
Thank you very much. And I'm glad and happy, excited to be here to talk a little bit about my passion.
Great. Can you tell us a little bit about how you came to work in your current position at the University of Wyoming?
Yeah, it all started with poultry judging in FFA in high school and really didn't know where it would lead to, but it led to a master's in undergrad at Mississippi State, where I focused on pre-harvest food safety under the direction of Dr. Aaron Keese. It was there really that I decided to pursue a PhD, and I did that under the direction of Dr. Stephen Rickey at the University of Arkansas, and really expanded upon the pre-harvest to the post-harvest food safety. When Dr. Stephen Rickey accepted the position as the director of the Meat Science and Animal Biologics Discovery Program at the University of Wisconsin-Madison, I was just graduating and accepted a position as a postdoc with him there, and really was able to expand beyond just poultry because my degrees previous to that have been poultry science. And that's my love, obviously, but got to expand to the other meat sectors and was able to expand upon beef and pork. And now here at the University of Wyoming, I get to expand upon that even more and go into lamb as well. So hence meat microbiology, not just poultry anymore, now into all of the meat sectors. And it's exciting. It's definitely what I've learned with poultry is being applied into those other sectors, but also learning a lot as I go there.
How much overlap is there between the meat quality or meat safety issues in those different sectors?
There are some difference with integration that does lead to differences in how we might be able to apply pre-harvest strategies. But at the post-harvest side, there are a lot of overlapping, at least technology, when we start to think about how we're going to apply these antimicrobial interventions. The pathogen target may not necessarily be the same. Some of our spoilage targets may be similar. The packaging technology, depending on what product you're looking at, may look different as well. And all of this together might mean that your overall targeting strategy, your multi-hurdle strategy might look a little different, but there are a lot of overlapping themes that help us to at least, when you start that poultry side, to move over to be able to keep up and bring something fresh to the table. At least in what I'm currently doing, we expanded upon an inorganic acid on the poultry side, and now we're trying to find a place for it and a useful place for it on the beef side. But just because it works on one matrice may not mean that it's necessarily going to be as effective on another matrice. So what may be effective on poultry, and that's been great because acidifiers work well, we have the buffering capacity of the skin, may not work necessarily well on a non-skin-on product in the beef industry or the pork industry. But we're trying to figure that out, right? It might be more effective against shelf life rather than maybe pathogens where we saw on poultry. But all of that, trying to put it together, like I said, it does have some overlap, but there are some nuances that I get to learn. And that's what's exciting to me, is to expand upon my current knowledge and try to be helpful to multiple matrices, right, to have food safety. But just to expand a little upon, one of the things that may not be consistent is the pathogen issues. So one of my interventions that I may know is really good for salmonella, I may not target salmonella on beef as my primary pathogen, right? I'm probably going to look at an S-Tech. So that might be a little bit different too when I look or think about my strategies and what research I might apply.
Working with nature and not against it. Chickens fed AX3 Digest consume significantly less feed and water to produce 1 pound of meat. Successful flock performance is determined during the first 10 days post-placement. AX3 Digest is a highly digestible novel protein that most improved in barn performance, bird health, and a drier litter. For more information, visit www.protecta.com.
Now, coming back to poultry, this is the Poultry Podcast Show. So what are the major pre-harvest microbiological threats that you're currently working on?
One of our threats specifically is going to be salmonella. We've heard a lot about it, but as well as Campylobacter jejuni. Knowing that it's there, it's in the background. I know you recently also had Dr. Elena Olson on here, and she does a lot with Campylobacter, and her and I came from the same lab. So we joke about it. It's in the background, it's hiding, it's always present, but it's harder to get rid of because it is there and it likes that community that it's present in. So that's one of our bigger challenges. But salmonella always is a challenge as well. So looking into those, how we might be able to strategize on the pre-harvest side. And that's really what led us into some of that organic acid application, maybe some of the different types of blends of these microencapsulated organic acids with maybe vanillin extract. We've looked into some of that, into how that might improve with the removal of antibiotics from poultry diets. Another concern that Dr. Swaggerty has collaborated with us previously on is necrotic enteritis and coccidiosis, as that's still prevalent and causing a lot of mortality and loss in the poultry industry. And so how can we apply those in that same sense to improve, not just reduce necrotic enteritis, but how do we improve the stability of that microbial ecology so that bird is more resistant? And that's the goal. But a lot of that starts on day 0. So a lot of these feeding strategies, we have to begin very early on and establish a strong microbial community, maybe get it to where it needs to be, right? A more stable community faster by day 14 when we start to see that coccidiosis or necrotic enteritis start to play more of a role in the development of that bird.
Okay, so not just human pathogens, but bird pathogens as well.
Yes, yeah. So foodborne pathogens, obviously very important, but one of the things that I would like to get into here in the future is when we obviously have dysbiosis, not only we're going to have bird health be decreased, but we're going to have these foodborne pathogens be more prevalent because of that. So trying to tie in that overlap and understand, disease, how does that impact our food safety as well? Because dysbiosis, that microbial ecology, is very important when we think about not just bird health, but we think about food safety as well.
So looking post-harvest and at spoilage organisms, so typically they're not the same microbes that we worry about from a food safety standpoint. But what are some of the major spoilage organisms that we need to be concerned about?
Yeah, so obviously with poultry, if we're thinking about aerobic packaging, Pseudomonas is always going to be one of our top. There's other organisms as well, a lot of them revolving in the lactic acid bacteria family. Or we even have one of the things that we've noticed more if we think about anaerobic packaging, like vacuum packaging, as we're finding more spore formers that are being more prevalent. So bacillus is popping up. We've seen that in the plant as well, more towards our scalding tanks when we've looked at microbial ecology throughout the plant. And then as we move to more of a long-term packaging, like you might see with a vacuum package, that's something that we're also seeing. And, I'll talk more about this, but we're also seeing when we start to apply our interventions that we're seeing a change in that typical ecology, right? Our typical spoilage organisms like Pseudomonas or lactic acid bacteria, we're moving from those organisms, we were reducing those with maybe inorganic acids, but when we start to apply these, we need to think about what else is in the background that, yes, we reduce these main spoilers, but there might be another one that's going to come into play, like maybe a acid tolerant spore former that might be more at play. So I had a recent paper that we looked at looking at an inorganic acid, and that's something that we did note. It didn't show up until 7 days after, typical spoilage would occur. So we were having an increase in shelf life, but at that end point, we weren't seeing, Pseudomonas or lactic acid bacteria. We saw bacillus. We saw more of that acid tolerant spore formers. And so we have to think about that and consider, here's our normal flora, right? We've got the lactics, we've got our Pseudomonas. This is our traditional flora. But when we start to apply these interventions, what's that background? What are we pushing forward to the front? Because when we start within microbial ecology on day 0, right, a fresh poultry product, we have a plethora of organisms. But when we get maybe to day 7, day 10, or when the end of spoilage, we have 1 or 2 dominant microorganisms that are really pushing to that forefront. And that also depends on packaging, right, intervention strategy. But that's kind of what we're seeing on our side on the spoilage realm.
So you might be solving one problem and opening the door for another one.
Yes.
But if you're extending the shelf life by another 7 days, we probably can't extend shelf life indefinitely.
Yes.
But is that enough to have an impact on the industry?
I believe so. With such a short turnaround on products, it is important just to have an extra 2 to 3 days. That will help us with our cold chain as well. And one of the projects that I'm getting into now, and this is a little bit different than more of our inorganic acids, but trying to see how, like I talked about, some diseases can impact food safety. Well, how can some stressors on the pre-harvest side impact spoilage and shelf life on the post-harvest level? So trying to look at how heat stress will impact the longevity of that product and that microbial ecology of the final product. And then is there a way that we can maybe use an inorganic or organic acid, something that is either currently on the market or a novel product, to try and counteract that, so that we, during summer months, right, we're not hitting an issue with our products spoiling much faster because of this heat stress that, right, weather is changing. And we're seeing hotter climate in the South, especially with, hotter days. And then we still might have cooling at night, but we're still having that heat stress occur. So we're going to try and look at that and look at over not just at the pre-harvest level, but take it all the way through the post-harvest and the shelf life. And then if we do, like I said, if we can have a 3 to 3-day extension, that can help us with the cold chain, get it to where it needs to go and to get it to the consumer and not spoil in the display case, which ultimately that money is going to more of our retailer loss than it would be at our industry loss, but it's still a loss regardless.
I'd like to remind our audience that if you find this or any of our previous topics worthwhile and informative, please subscribe to the Poultry Podcast Show YouTube channel by clicking on the bell icon to receive our notifications. You can also share the video if you've learned something new today. So Dana, much of your work has involved the use of organic and inorganic acids to control microbes. What's the difference between the two categories?
One of the big things is obviously organic is more natural, it's going to be found in the environment, where inorganic, we might be manufacturing these acids. A lot of times with inorganic as well is you're going to have a lower pKa, where a lot of the organic acids that we're using are typically short chain fatty acids that are going to have a weaker pKa, which just means that they will typically alter the pH of the environment and act indirectly on those cells that we're targeting, whereas we might have direct targeting with our inorganic acids through that lower pKa. As well, what we might see as a concern with some of these different acids, right, are organic, a lot of those being weak acids that are used in the industry versus our inorganic, which might be a stronger acid. For example, a lot of my research focuses on sodium acid sulfate, which has a pKa below 2. But one of the concerns we might have there is water retention. But it has been very effective against salmonella, so especially on poultry. And that's the one as well that we've tested shelf life and done a preliminary study, and we're about to publish a more thorough study that we've just recently completed this past year. But when we looked at the microbial ecology over time, that's what I was referring to when I said, we increased shelf life, and we did it by 7 days. But as well, we saw that shift in microbial ecology with a reduction of our lactics and more of our typical spoilage organisms. And then by day 21, right, much further than we would typically have a product. That's when we saw more acid tolerant spore formers remaining in that population. So it's a promising product to use, but if we can also pair it with maybe an organic acid throughout the process, we might have a more sustained reduction and have a better product in the end. But again, these are short term. We don't use them for long dips. A lot of the organic or inorganic acid use is going to be a 5 to 10 seconds, or maybe 15 seconds at most. Mm-hmm. They typically occur as dips, but you also may see them as sprays as well. But because we're worried about water retention, maybe whitening of the skin, those are going to be short duration dips that are primarily used for antimicrobial efficacy that we're using so that we don't have any detriment to product quality as well. The other big thing that I do see is, even though it might be an inorganic acid, it may not necessarily be deemed organic, but a lot of times they're still deemed generally recognized as safe, sometimes even by the EPA as a safer alternative product. So thinking about sodium acid sulfate, it is on the EPA's list as a safer alternative, as well as is generally recognized as safe. So they're still safe products to be utilized on products like we are going to consume, right? Meat products as an antimicrobial intervention. Another inorganic acid that we've used is acidified sodium chloride, and those are also short-term duration dips, and they've been effective as well. What we're seeing with those is similarly, we might have a reduction in our traditional microbial spoilage organisms like lactics, but we do see some of the increase, or maybe an enrichment, you could say, of some of these more bacillus-like microorganisms. So we're seeing some of those consistencies because they are more acid tolerant. But like we mentioned, you're not probably going to see them until a lot longer of shelf life when you're not eating that product. So it's pretty promising work, and we're very excited about it.
Oh, yeah. So maybe if I can summarize, the inorganic acids seem to be more of a disinfectant approach. And as a nutritionist, I'm more familiar with organic acids as feed supplements and maybe trying to more subtly shift the microbiome pre-harvest. So is that a fair assessment, or are there post-harvest applications of organic acids as well?
Yeah. So fair assumption, of course. And a lot of our organic acids that are still utilized are primarily going to be utilized more in beef or swine production. So in poultry, I'm not seeing a higher amount of lactic acid used. There is sometimes citric acid will be used to lower the pH of maybe another product. Peracetic acid does have an organic acid in it, but it's a combination. And peracetic acid is used commonly across all of the meat matrices as an antimicrobial intervention, and it is very effective as well. But when we compare it against some of these inorganic acids, that's where we're seeing some of these differences in microbial ecology. But like you're saying, the ultimate goal of all of them is to reduce all organisms or to lower that initial load. Primarily are pathogens, but the initial load, if we can lower it, then we know that we're going to have a longer shelf life and hopefully a safer product. That's the goal. But what we're seeing is, at least microbial ecology wise, that there is a different shift between the different products, that because it has a lower pKa, it is acting more as a complete disinfectant, with only those that are very acid tolerant remaining, which is promising. But we have to, again, like I said, keep an account. It's a lower pKa, so making sure that we don't reduce product quality while we're using these is very important, and is constantly in the back of our head when we try to implement these interventions.
Yeah, is there a risk of affecting the taste of the products as well if you use too high a concentration or too long immersion?
Yeah, so not only can you impact taste, you can impact lipid oxidation is one of the things we're really concerned about with some of these products. Another is color, because especially on poultry products, when you start to lower the pH, we get a lot of whitening of the skin. And that's something that we don't want to happen. So like I mentioned, we did a more thorough shelf life study, and that's one of the things we took account is our specifically color. So making sure that we're not whitening the skin, we're not decreasing the yellow of the skin, or decreasing the redness of that skin, and maintaining that product integrity. The other is obviously we could look at other volatile organic compounds that are produced off of that product as shelf life goes through. Those are a little bit more in depth, and we are not at that point in the stage of evaluating some of these products. But like I said, color, taste. The other that is really important is water retention. So, it might be great in beef where we might not want to take up water, right? They have, I think it's 0.5% of water pickup in trim, whereas poultry, we have a little bit more water pickup is allowed. But when you start to lower that pH, you reduce that water holding capacity. And that's a concern, right? We're then going to have a decrease probably in our product quality when it comes to an increase in dryness of that product. So it might be a less tender product, a more chewy product. And that's not something that we want to see coming to our consumer, right? You want a quality chicken breast. You don't want something that's going to be tougher to chew, right? So that's one of our considerations when we think about these more acidic compounds and using at the post-harvest level.
Okay. Is there a difference in how you would use these products in a water chill versus an air chill processing plant?
Yeah, so most likely, like I said, a lot of these are short-term durations. So we're not going to apply it necessarily in the immersion chiller that might last for 90 minutes. There could be some use, especially when we think about the inorganic acids for the post-chiller or part dip. But otherwise, a lot of spray application is where we could see that. And that would be most applied not just to, right, where we have immersion chillers, but we could also see that in air chilling facilities. Now, there hasn't been a lot of evaluation on some of these inorganic acids, like the sodium acid sulfate, when looking at air chilling and spraying it throughout that duration of air chilling. There might be some concern, again, with reducing water holding capacity in that area, as well as having more whitening of the skin the longer you're using that product. However, if you were to use it at the end of chilling, that might be more appropriate. or when we have cut up, where we start to see more of these pathogen concerns, because we're starting to see, right, when you break that product up, you're releasing salmonella maybe from the joints or from the internal parts of that product. And that's where we see a greater prevalence of salmonella. So that might be a better application for it, as well as at the part step after debone or during debone.
Yeah, that's really interesting. And it sounds like you're finding some effective means of controlling spoilage organisms and pathogens.
Yeah, that's the goal. That's the goal.
Well, it's nice when some of your efforts see success. So let's change topics a little bit. How have you found the shift from being a postdoctoral researcher to being a new faculty member?
Yeah, that's a great question. I will say the first year was not that difficult of a transition. Trying to get everything started was a little slower. Mm-hmm. My PhD and postdoc training were very helpful in getting me prepared to write grants, to submit grants, to work with industry and see what problems we might be able to address, to get support letters for those grants, to make sure that I had all the equipment and processes for the lab that was well handled and well understood, because I helped Dr. Ricky's lab start in Wisconsin-Madison. So I knew what instruments I needed to purchase from the get-go. And then again, the grant writing, we did a lot of that, the papers, making sure manuscripts were submitted at the same time. So juggling a lot of these things, I did a lot of that in my postdoc and was very helpful to transition to my first year. However, I don't know if other young faculty experience this as well, but they take it kind of easy on you in your first year and get you used to it before they start signing you up for all of the committees, and before I start signing myself for all the committees as well. So that first year I taught food microbiology. I taught two classes. I taught food microbiology and then a lab as well that was food microbiology oriented, but more for industry segment. And again, much easier of a year. I was getting into the groove of things. And then this year, everything's ramped up. I have grants. I have a graduate student, and we are trying to recruit more graduate students, trying to carry that with manuscripts and all of the extra committees, right? Because my position is 35% teaching, 5% service, and 60% research. But that 5% service, it ends up adding as you go through, the more that you expand yourself. So I'm keeping up with it and I'm trying my best. But I will say the second year, if I had to give advice to new faculty, is make sure in your first year that don't get too comfortable, because it does increase that second year, and to start kind of prepping yourself for that second year so that you're not overwhelmed and you're ready for it. But it's been an excellent transition. And like I said, I'm very well prepared. I am very appreciative of my mentor, Dr. Stephen Ricky, for getting me a lot, or allowing me to have those experiences that, may have seemed like a lot at the time, but when you come into being an assistant professor, it's priceless. You can't replace that experience. But like I said, if I had to give advice, it'd be make sure in your first year that you don't get too comfortable. Prep for the second year, because that's when the real fun starts, because you'll start to see your grants come in and you'll start to see students, and your own research is really going to ramp up at that time. And then as well, I taught 3 classes this past semester in the spring semester, which was a lot for one semester, especially. Yeah, one of them being new to me. Not that Intro to Food Science is new in my mind, but it's a newer class that I had to teach that I didn't teach before, where obviously food micro is my passion, and food science is very well needed, but it's a different set of students when you start to teach freshmen as well. So make sure, that would be another advice to incoming faculty, is make sure that you get that experience when you can of teaching not just graduate level or, senior level students, but make sure you're getting that experience as teaching undergrads, especially freshmen, because that's a lot different of a class environment that you'll have to engage with than engaging with upperclassmen. And it was an exciting challenge, but it was still a challenge to make sure that those students were getting everything they needed to be successful while teaching, upperclassmen levels and making sure that, the lab had everything that it needed and it was going smoothly at the same time. So
when it comes to raising healthy animals, you need more than the right solutions. You need the right partner who brings decades of industry expertise and a global team to put that knowledge to work for the advancement of your operation. At Phibro Animal Health Corporation, we are proud to work with you as your trusted partner.
How do you think you're going to approach mentorship, grad students and undergrads, and maybe how is that shaped by your mentors? You talked a little bit about that already, but...
Yeah. So being a newer mentor and not having an established lab. So a lot of what I was used to, right? I came from an established lab. He had, postdocs at the time. He had PhD students and master students and undergrads. So there was a level of, okay, so if your mentor is busy, you could go to another student in the lab. It's a little bit different for an assistant professor when you don't have an established lab hierarchy or an established lab personnel. So coming in yourself, you have to hire a graduate student, right? Or an undergraduate. At this point, I have one graduate student and she's excellent, but it's a lot more hands-on mentoring at this point. And as she progresses and she's accepted a PhD with me that she'll start next year. So we have that kind of plan in place for her graduate studies. So at this point, it's much more hands-on. We're meeting on a weekly basis, maybe multiple times a week, depending on what's going on in the lab. I'm more in the lab at this point because you can't just do a project with one person. That would be very miserable and long. And I'm not about to make my students stay in the lab 24/7. So right that now it's much more being present, being able to have her ask questions. We did start, and this is my style of mentorship, is to start with a plan. You may not always stick to the plan, but having that student write out, a rough literature review, even if it's 10 pages, and write methodology and expected results to their project. And that way, when they come into their committee meeting, they know what they want to do, and we can get advice from those committee members, and it's more directed, even if it's at the master's level. So that's something that we work towards the first semester. And then the second semester, she had her committee meeting early on. And now we're running into her research and making sure that's accomplished so that by year, since we're heading into year 2, she can make sure that she has everything analyzed and written by the time she needs to defend and start her PhD work.
That sounds like a great approach. Well, Dana, thank you very much for your time. I really appreciate you talking to us today.
Of course.
And hopefully we'll get a chance to talk again in the future.
Yes, thank you so much again for having me.
And thanks to our audience. If you enjoyed this interview, please give us a thumbs up on whatever platform you're using to view the podcast. I'm Doug Corver, and I'll see you next time on the Poultry Podcast Show.